Welcome. Today we're diving into one of the most fundamental concepts in computer science, arrays. Arrays are a basic data structure that allow us to store multiple values in a single variable. Think of them as containers that hold a collection of items, all of the same type, neatly organized in a specific order. Whether you're just starting out or brushing up on your skills, understanding arrays is essential for efficient programming. In this video, we'll explore what arrays are, how they work, and why they're so important in data structures. Let's get started by defining what an array actually is. Array is a collection of elements, each identified by an index or a key. All elements in an array are stored in contiguous memory locations, which means they are placed next to each other in the computer's memory. This arrangement makes accessing any element in the array very fast and efficient. Arrays are used in almost every programming language, from Python and Java to C and JavaScript. They are the building blocks for more complex data structures and algorithms. Now let's look at how arrays are represented in memory and why this matters. Arrays store their elements in consecutive memory locations. This means that if you know the starting address of the array and the size of each element, you can calculate the address of any element instantly. This property is what makes arrays so efficient for accessing data. For example, if you want the third item in an array, you simply jump to the correct memory location using a simple calculation. This direct access is a key advantage of arrays over other data structures like linked lists, where you have to traverse nodes one by one. Each element in an array is accessed using an index. In most programming languages, arrays are zero-indexed, meaning the first element is at index 0, the second at index 1, and so on. This indexing system allows for quick and easy retrieval of any element. For example, if you have an array of 5 numbers, you can access the third number by referencing index 2. Understanding how indexing works is crucial for avoiding errors and making the most of arrays in your program. Arrays come in different types, depending on the programming language and the data they hold. The most common type is the one-dimensional array, which is simply a list of elements. There are also multi-dimensional arrays, like two-dimensional arrays, which can be thought of as tables or matrices. These are useful for representing grids, images, or any data that has rows and columns. Understanding the different types of arrays helps you choose the right structure for your specific problem. One-dimensional array is the simplest form of an array. It's just a single row of elements, all of the same type. For example, an array of integers might look like 2, 4, 6, 8, 10. You can access each number using its index, starting from 0. One-dimensional arrays are perfect for storing lists of items, such as scores, names, or even objects. They're easy to use and form the foundation for more complex data structure. Multi-dimensional arrays extend the concept of arrays to more than one dimension. The most common is the two-dimensional array, which you can visualize as a table with rows and columns. For example, a 3x3 matrix is a two-dimensional array with 3 rows and 3 columns. These arrays are useful for representing data like spreadsheets, game boards, or pixel grids and images. Accessing elements requires 2 indices, one for the row and one for the column. Use an array, you first need to declare it. Declaration involves specifying the type of elements the array will hold and, in some languages, the number of elements it can contain. For example, in Java, you might write int numbers equals new int 5 to declare an array of 5 integers. In Python, arrays are often implemented as lists, and you can simply write numbers equals 2, 4, 6, 8, 10. The declaration sets up the structure in memory, ready for use. For declaring an array, you often want to initialize it with values. Initialization means assigning values to each element in the array. This can be done at the time of declaration or later in the code. For example, you can declare and initialize an array in one line. Int numbers equals 1, 2, 3, 4, 5. Proper initialization ensures that your array contains meaningful data and helps prevent bugs caused by uninitialized elements. Accessing elements in an array is straightforward. You use the array's name followed by the index in square brackets. For example, numbers2 retrieves the third element in the array. This direct access is one of the main reasons arrays are so popular. It allows you to quickly read or modify any value without looping through the entire structure. Just remember that indexing usually starts at 0, so always double-check your indices. You can change the value of any element in an array by assigning a new value to a specific index. For example, numbers1 equals 10 changes the second element to 10. This flexibility makes arrays ideal for situations where data needs to be updated frequently. Just be careful not to access indices outside the array's bounds, as this can cause errors or unexpected behavior in your program. Knowing the length or size of an array is important for many operations, such as looping through all elements. Most programming languages provide a way to get the array's length. For example, in Java you use arrayLength, while in Python you use len_array. Always use the array's length property to avoid going out of bounds and causing errors. This practice helps keep your code safe and efficient. One of the most common operations with arrays is looping through all the elements. This is typically done with a for loop, which uses the array's length to determine how many times to iterate. For example, for int I equals 0, arraylength I++ lets you access each element in turn. Looping is essential for processing data, searching for values, or performing calculations on all elements. Arrays support a variety of operations, such as searching for a value, sorting elements, or copying data to another array. These operations are often built into programming languages or available through libraries. Understanding how to perform these tasks efficiently is key to working with arrays. For example, you might use a loop to search for a specific value or a built-in function to sort the array in ascending order. Searching for a value in an array is a common task. The simplest way is to use a linear search, which checks each element one by one until it finds the target value. This method works well for small arrays but can be slow for larger ones. Some languages offer built-in search functions, and for sorted arrays you can use more efficient algorithms like binary search. Choosing the right search method depends on your data and requirement. Sorting is another common operation with arrays. You might want to arrange numbers in ascending order or sort strings alphabetically. Many programming languages provide built-in sorting methods such as sort in Python or ArraySort in Java. Sorting makes it easier to search for values and analyze data. Understanding how sorting works helps you write more efficient and readable code. Sometimes you need to create a copy of an array. This can be done manually by looping through each element and assigning it to a new array or by using built-in functions. For example, in Java you can use arrays copy of, while in Python slicing like array creates a copy. Copying arrays is useful when you want to work with the same data in different ways without affecting the original. While arrays are powerful, they do have limitations. The size of an array is usually fixed when it's created, meaning you can't easily add or remove elements later. Also, all elements must be of the same type. If you need a more flexible structure, you might consider using lists or other dynamic data structures. Understanding these limitations helps you choose the right tool for your programming tasks. Dynamic arrays, like Python's lists or Java's ArrayList, address some of the limitations of regular arrays. They can grow or shrink as needed, allowing you to add or remove elements easily. Under the hood, dynamic arrays still use regular arrays, but they automatically handle resizing and memory management. This flexibility makes them a popular choice for many applications. Arrays and lists are often confused, but they have important differences. Arrays have a fixed size and require all elements to be of the same type. Lists, on the other hand, can grow or shrink and may allow different types of elements depending on the language. Understanding when to use each structure is key to writing efficient and maintainable code. Arrays are implemented differently in various programming languages. In C, arrays are low-level and require manual memory management. In Java, arrays are objects with built-in properties. Python uses lists as its primary array-like structure, offering more flexibility. Understanding these differences helps you adapt your skills to different programming environments and choose the right approach for your project. Arrays are used in countless applications, from storing user data and managing game scores to representing images and processing sensor data. Their efficiency and simplicity make them a go-to choice for many programming tasks. Whether you're building a simple calculator or a complex data analysis tool, arrays are likely to play a key role in your solution. Many algorithms rely on arrays for storing and processing data. Sorting algorithms like bubble sort and quicksort use arrays to organize elements. Searching algorithms such as linear and binary search operate directly on arrays. Mastering arrays is essential for understanding and implementing these fundamental algorithms efficiently. Arrays are memory efficient because they store elements in contiguous locations. This layout reduces overhead and allows for fast access. However, if you allocate a large array and don't use all the elements, you might waste memory. It's important to balance the size of your arrays with your program's needs to ensure optimal performance. One common mistake when working with arrays is accessing an index that's outside the valid range. This is called an out-of-bounds error. In some languages, this causes a crash or exception. In others, it may lead to unpredictable behavior. Always check the array's length before accessing elements to prevent these errors and keep your programs running smoothly. Multidimensional arrays are especially useful for representing complex data. For example, a two-dimensional array can store a chessboard's state, a spreadsheet's data, or an image's pixels. By using multiple indices, you can efficiently organize and access data in rows and columns, making your code more readable and powerful. Jagged arrays, also known as arrays of arrays, are a special type of multidimensional array where each row can have a different length. This is useful when you need to store data in a non-uniform structure, such as a list of lists with varying sizes. Jagged arrays offer flexibility while still providing the benefits of array-based storage. Traversing an array means visiting each element, usually with a loop. This is essential for tasks like searching, updating, or displaying data. You can use for loops, while loops, or even specialized iterators depending on the language. Mastering array traversal is a key programming skill that will help you manipulate data efficiently. You can pass arrays to functions as arguments, allowing you to process or modify their contents within the function. In some languages, arrays are passed by reference, meaning changes inside the function affect the original array. In others, they may be copied. Understanding how your language handles array passing is important for writing correct and efficient code. Functions can also return arrays, allowing you to generate and use collections of data dynamically. For example, a function might create an array of random numbers and return it to the caller. This technique is useful for modular programming where you break down complex tasks into smaller, reusable functions. In languages like C and C++, arrays are closely tied to pointers. A pointer can reference the starting address of an array, allowing for powerful and flexible data manipulation. However, working with pointers requires careful attention to memory management and can lead to bugs if not handled properly. Understanding pointers is crucial for advanced array operations. Array slicing allows you to create a new array from a subset of an existing one. For example, in Python, array1 4 creates a new array with elements from index 1 to 3. Slicing is a powerful feature for extracting or modifying parts of your data without affecting the original array. It's especially useful for data analysis and manipulation. Resizing an array means changing its length after creation. In most languages, regular arrays cannot be resized directly. Instead, you create a new array with the desired size and copy the elements over. Dynamic arrays handle resizing automatically, making them more convenient for situations where the amount of data changes frequently. When you create an array, the computer allocates a block of memory large enough to hold all its elements. This allocation is usually done at once, ensuring that the elements are stored together. Efficient memory allocation is important for performance, especially when working with large arrays or in memory-constrained environments. Languages with automatic memory management like Java or Python, arrays that are no longer needed are cleaned up by the garbage collector. This process frees up memory and prevents leaks. However, in languages like C, you must manually release memory used by arrays. Understanding garbage collection helps you write safer and more efficient programs. Some programming languages offer both mutable and immutable arrays. Mutable arrays can be changed after creation, while immutable arrays cannot. Immutable arrays are useful for ensuring data consistency and avoiding accidental changes. Choosing between mutable and immutable arrays depends on your application's needs and the level of safety required. Sparse arrays are arrays where most elements are empty or have a default value. They are useful for representing data with lots of gaps, such as matrices with many zeros. Special techniques are used to store sparse arrays efficiently, saving memory and improving performance when dealing with large, sparse datasets. Associative arrays, also known as maps or dictionaries, use keys instead of numeric indices to access elements. While not traditional arrays, they're closely related and offer powerful ways to organize and retrieve data. Associative arrays are especially useful when you need to map unique identifiers to values, like storing user profiles by username. Arrays are everywhere in real-world software projects. They're used in databases, graphics processing, scientific computing, and more. Their speed and simplicity make them a favorite for handling large amounts of data. By mastering arrays, you'll be better equipped to tackle a wide range of programming challenges in any field. To get the most out of arrays, follow best practices like always checking array bounds, initializing elements, and choosing the right type for your data. Use built-in functions when possible and prefer dynamic arrays when you need flexibility. These habits will help you write safer, more efficient, and maintainable code. Arrays are known for their performance benefits, especially when it comes to accessing and updating elements. Their contiguous memory layout allows for fast operations, making them ideal for time-sensitive applications. However, be mindful of their limitations such as fixed size and type restrictions to avoid performance pitfalls. Arrays serve as the foundation for many other data structures such as stacks, queues, and heaps. By understanding arrays, you'll find it easier to learn and implement these more advanced structures. Arrays provide the building blocks for efficient data storage and manipulation in computer science. Let's recap what we've learned about arrays. They are a fundamental data structure for storing collections of elements, offering fast access and efficient memory usage. Arrays come in various types and are used in countless applications. Understanding their strengths and limitations will help you write better code and solve complex problems more effectively. If you want to deepen your understanding of arrays, there are plenty of resources available. Online tutorials, textbooks, and coding exercises can help you practice and master array concepts. Exploring real-world examples and experimenting with code will solidify your knowledge and prepare you for more advanced data structures. Congratulations on completing this introduction to arrays and data structures. You now have a solid foundation for working with arrays in any programming language. As you continue your journey, try implementing arrays in your own projects and explore how they interact with other data structures. Mastery of arrays will open the door to more advanced topics and make you a more effective programmer.